Today I'm going to talk about the RTV ESC, so the motor controller that works well with the electronics that I've designed for it. Now, you can probably see there's a few ESCs here, motor controllers, and well, Traxxas, as much as they make a really good one, and it is a good one, and the issue that I had with them was phantom drain was one. If you don't unplug the battery drains. And they really didn't integrate with other electronics well. And I've tried all of these, and well, and some non-Traxxas, and some brushless and brushed. I've tried a whole bunch. In the end, I found one that integrated well, was very powerful. It can knock this thing's socks off, which is good. Maybe not as powerful as the Valinian, but it can be if you just pick a different motor. I prefer the 13.5 turn. I think it's too much anyway, but still it's good. If you really wanted to go with a 10.5 turn, you could. This controller supports it. So the controller that I use, and the one that integrates really well with the Traxxas, this isn't Traxxas? What are you talking about? That integrates well with the RTV that I built is the 10BL120G2 Censored Brushless Electronic Speed Controller. I guess that's what ESC stands for, doesn't it? It's made by Hobbywing, and they work. And I like that they work, and they just work. I like that a lot. So making this fit in there, you want to get the one that doesn't have connectors on it, because we're going to add our connectors, and we're going to cut the wires a little bit differently. They're not going to be this long. There's not a lot of room in there. You may not know that, but you're going to know it if you're building one. There's not a lot of room in there. There's like square millimeters of space here and there to put stuff. So we want to cut these to the right length, because trying to coil that up inside is just unacceptable. So I'm going to show you how, where to cut them, where to integrate the switch with the Man Cave Puzzles boards, and yeah, let's get that done. So the first thing you want to do is mark off where you're going to cut these wires, and you start off with the red one. So it's 22 millimeters to where you cut it, and then add another 6 millimeters or so of space. Now on the 22 millimeter mark, you score the wire, score the insulation, you don't score the wire, and then cut a little slit in it, and then lightly score on the side that you're going to keep, because you don't want to cut the wires with this. What you really want to do is just score it so that the insulation comes off. Now why do you do it? So that you are keeping the wire on this side. Well, you see how nicely compact this is? If you were to cut this off, if I were to say, oh, let's just cut this off, and then I will strip that, look what you get. Try and make that into a nice, compact space like you can do with this. Yeah, sure, that's fine. That looks great until you apply some pressure to it, and then it's flat. If you're wondering why I'm not using this soldering iron, my bigger soldering iron is much better with this gauge of wire. This wire is huge. So I will hold the wire with something that won't let me burn my hands. I might actually give it a little twist here. Get it a little closer so it's more compact. And turn on my extraction fan. So I don't want to breathe this stuff in any more than anyone else does. You can cool it down a little bit faster. Then, when you cut it off, it's pretty decent. And if you don't like the shape of it, I would suggest you get something to shape it. Nice and round. Now, why does it have to be nice and round? Well, nothing has to be anything, but if you want to connect it to the motor connectors, I guess we can show that one. So I'm going to lose this. That was my 22 millimeters. I'll get the... No, that one's not going to the motor connector. Oh, you know what? I'll cut one that is. Let's do the blue. So blue, we cut off 115 millimeters, yellow 105, orange 95, and the switch. From here we go 45 millimeters to where we cut it off. So let's get this one done. Take a look at this one. Inspection. Looks decent. We'll cut this guy off. And make it a little more round. There you go. Now, when we're doing this, there are 3 connectors on the motor that come off. They're hard to get off with your fingers, but you can get them off with pliers a lot more easily. Heat shrink, and we'll do it about like that. And I've got a hot air soldering station, so I use my hot air from the soldering station, but if you wanted, you could just use your soldering iron to do this and just get it hot with the heat shrink. I much prefer using my hot air iron. It just does a really nice job, and it looks and doesn't mark it. You can see there's some little marks on there. Just makes it so nice. So there's one done. And it's the same for the others. Different lengths. And this one, oh, that's done. That's nice. This goes to a Dean's connector. And the Dean's connector is polarity sensitive, so you got to do it the right way. I will get a Dean's connector. Now when you're doing the connector, you have to put the heat shrink on first. Unlike this one where you can put it on after. When the connector's on there, you won't fit heat shrink over it, so you got to make sure you put that on first. And the one you're putting on is a, I don't know, what do you call that? It looks male to me. Some heat shrink, please, my good man. This fit? Yes, very good. Make it about that long. And about that long. Put the heat shrink on first. That's always a good idea. And put it far enough away. If you leave the heat shrink right here, what's going to end up happening is this will get so hot it'll shrink here and you won't be able to move it up. So get it far away. Far is better in this case. Now, this one, actually the flat tab here has a plus sign on it. Well, guess which one goes there? Yes, red. You guessed correctly. You're a genius. Alright. I want to put this somewhere where I can push on it a little. I think that's good. And I've got a hardwood surface here that I solder on all the time. I was playing with it with my laser engraver. That was kind of fun. So I'll tin these. This one on the outside. Yeah, okay, that worked really well. And I know this is probably pretty hot, so I'm not going to touch it with my fingers yet. Alright. I could use my vise instead. Well, let's see. Get that where you can see it. Let's see. Not where you can see it. I'd say that's all right. I'll try and do it goodly for you. Alrighty. So I like to do, there are some sides. This one has a little void in it. This one has a bump on it. I like to do it on the outside here so it's away. So lots of tin there. I'm going to do it on this side. Whew. Okay, come on. Take the smoke, please. Okay, tinned. Now, we know that this one's red. And I am going to hold on to it with a pair of pliers because I don't want to burn my fingers and I want to have good control. Yay, come on, don't do that. Jeez Louise. Yay! Oh, okay, that was really hot. Imagine that hot. Try and get this in the place where it doesn't have the serrated parts so it doesn't mark the wire too much. The solder just sort of sinks into where you wanted it to go. Best description I could give you of flow. It's not short for Florence, in case you're wondering. So I'll get this again on the non-serrated part and give me some traction to hold it in place here. If you're wondering why I heat the wire first, I think the wire is a lot easier at taking heat, a lot better at taking heat than the connector. The connector's got plastic on it, so I heat the wire heats the connector, and when all that happens, you get a good connection. So there you go. 2 good connections. They are going to be very hot. Yeah. But they look good. This is a very sturdy connection. I like it very much. And the reason why we cut part of the red off is because we're actually turning a corner with this thing. And what that does is allows a natural turn of the corner, as you can see. Alright, you don't want to move this up too close when it's still hot. Yeah, it's okay. And jam it up there as hard as you can to cover everything. I think I might have made that. I think I might have used heat shrink that's too small on this one. Wow, that's really tight. Oh no, there we go. Got it covered. Alright, 1. After you've soldered on the battery connector, but before you take off the switch, it would be a good idea to program the ESC with the programming card that you have. Now remember, the programming is different than what comes on the programming card. There's a sticker that comes in with the ESC that has 1 to 12 program functions. Let's go through all of these values for a smooth running RTV. I'm just going to use a jumper to turn this on. There we go. So it's on. And it'll get to number 1. And we want the value to be 2. If we wanted to value something else, we could run through the values and then press OK to program it. So item 1 we want as 2. Item 2 we want as 6. And that is the cutoff voltage. Because this is a LiPo battery, we want very high cutoff voltage. We don't want this thing dropping too low before the ESC cuts out. So that's 2. 3 is punch. Level 3 is a solid level for acceleration that doesn't make the RTV flip over on its back. Drag brake force, I put that at 0. That is the force that it would be like what a brushed motor would give you. Braking force, we put that at 75, maximum brake force at 75%. That seems safe. Reverse force, maximum 75% again. I do find when the RTV goes backwards that it isn't as stable as running forward. Sometimes the wheels will wobble and it'll go off in funny directions depending on how you've got it adjusted. So 75 is good there. The neutral range. We want the neutral range to be 12%. The reason we want that is that we're dealing with almost antiques when it comes to these transmitters, and we want to have a little leeway where the neutral is. Boost timing, we've got that at 12 degrees. And I was told that the turbo timing, we didn't really need it for this thing, so I left it at 1. Turbo delay, you do want a little bit of delay before this thing takes off like a bat out of hell. Back voltage, you need that at 6 volts. It must be at 6 volts because the servos that we use are not rated for, they're not high voltage servos, so you'd blow them otherwise. And the last one, motor rotation, you want counterclockwise for this to run forward when you push forward. All right, and now you can cut off the switch. All right, these are going to go down there. That one we don't need to deal with. This one we need to deal with. And we are cutting off, what do we say, 45 millimeters from here. 45 millimeter, huh? 45 millimeter, about here. From the switch right there. That's what we're cutting off. So we'll get rid of that. Not going to use that. And the wires we use are the red and black. So the white one also gets cut real short. We're not going to use that, so just cut it off. It's fine. Come on. So you're going to want to separate these so you can put a little bit of heat shrink on them. Or you can put it on the other side. I guess it's all right. Yeah. I know some people don't use frown on wire strippers for stripping wire. Yes, I realize that. You know, I've been doing this for over 40 years. I sort of have the hang of it. And yes, I make mistakes like everyone else. All right, and this one, the connector. So this connector actually will come with the boards if you've ordered the boards from me, because this is the connector that you connect to the ESC. Doesn't have to be that long. Let's go with that long. Yeah, how long is that? Oh, let's go with 45 millimeters. Yeah, that was it. Perfect. Those. And keep it all dark. See if that one will do. Maybe we want this one a little longer. I'll go with that. That's going to be the whole thing. Watch out for the stray wires. You certainly don't want these things shorting. That would be bad. About yay long. And if I have a preference, I am going to put heat shrink on power, which would be the red. And then I'll put the big piece over both the red and the black. Straighten that. So I straighten that down so when the heat shrink comes over, it's not going to catch on it. Let's get this going here. All right. Nicely covered. I shouldn't be singing during the video. Maybe I should have some background music on to drown out my melodic voice. There we go. And there you have it. So this fan draws air down through this heatsink. And the issue with that is this fan sits right underneath where the smoke is made. So what we do, let's cheat. Let's just turn the fan upside down so it blows the smoke up. And that's okay. It'll suck the air through the heatsink instead. You know, big deal. We turn upside down. And there it was gone. And there's just, it's just threads. These are self-tapping screws, and they thread right into holes between the heatsink, the aluminum parts of the heatsink. So just find the same general spot you were in, and you should be able to screw them in no problem. And don't screw it all the way. Don't screw it all the way down the first one. Get the others in first. If you screw the first one down and it's too rigid, it'll be hard to find the holes for the others. So a little bit loose still. Now, one thing with this, don't push on the fan like I did. I broke one already. I just pushed really hard on this because I was trying to push it in. So you're going to have to push where the screws are. Don't push in the center of the fan. Good advice. And try not to put the screws in the middle of the fan either. Now you can tighten up. Not that it has to be that tight, but it should be tight enough so that the screws don't come out when you're driving. The sensor wire. It's quite silly, but I like it. Alright, next. What is... So on the sensor wire, there's... you can see the connectors are at the back. Like if you're taking a look at this, they're at that end. And then you take a look here. Oh, the little pokies, the little pins are at the back. So I know that this goes in this way. And it's a good idea to know that before you start, because these things do not go in easily. All right, so that one's done. And as you're installing the motor, or before, you can do it either before or as. This one, the pins are that way. The pins are that way. It would go in this way. Just saying. I'll be taking this off, but this is just to show you. It's got to go in all the way. You can see this one is a little bit crooked, so straighten it out by pushing that in a little bit further. And there you go. And A, B, and C. They are marked here. A is blue. A is blue. That's A. B is yellow. And don't be too worried about connecting these right away. You can actually connect, well, actually I recommend connecting them when you've got it in the RTV. There you go. Because this one sits something like, where does it sit? Oh yeah, it's something like this inside. So I forgot to put the connector on, the power connector for the boards, and I use a JST power connector, and this is the end that you have to add to the ESC, not this end. The end that they call female that really looks male to me, but whatever. All right, we're gonna do, let's do the same length as this. That length. This actually ends up running through a pretty massive filter. These ESCs create so much noise, so much electronic noise. It's a bit ridiculous. Turn that back on. And let's tin these. Now, I hope you can figure this out. That's a joke. I know you can. black to black. And you do need a big soldering iron for this one too, because you have to get all of that solder to at least melt on this side. Yeah, it's a big job. I think we're starting. Okay, that don't look too bad. Sometimes it's good to add a tiny bit of solder because I have flux built into that solder, so the flux that's in the solder can, I don't know, for lack of a better term, loosen up the solder that's already there. It looks fabulous. And that is the last piece. Now, you might say, oh, wow, you know, that might break off. Yep, it might. Chances are it's not going to, because once you install this one time, there's very little chance you're going to be taking this out often. Well, I hope that was informative and that you now have a ready to integrate ESC and motor ready to put in your RTV. Thanks for watching.